Section 6.4, Other Units for Solution Concentrations. In this section, we're going to learn how to calculate a few other units of concentration. Mass percentage, volume mass percentage, and parts per million / parts per billion. Okay, let's start with mass percentage. Now, earlier in this chapter, we talked about percent composition, which essentially is just a mass percentage of elements in a compound. We can also have mass percentage as parts of a mixture. So this is really calculated the exact same way. Instead, when we're talking about percent composition, we're just specifically talking about one compound. Here, we're talking about a mixture. Now, some other names for mass percentage are percent mass, percent weight, or weight over weight percent, which is represented as W over W percentage. To calculate mass percent, it is simply the mass of the component you're interested in divided by the total mass of the solution, and then again multiplied by 100% to put it in a percentage. So let's just look at an example. A 5-gram sample of spinal fluid contains 3.75 milligrams, which is 0.00375 grams, of glucose. What is the percent by mass of glucose in spinal fluid? So again, percent mass is mass component divided by mass of solution times 100%. The only real caveat here is those masses, they have to have the same units. So we've got 5-gram sample of spinal fluid, so we need to use the 0.00375 grams of glucose. Okay, so that was the conversion that I did to do this. So the percent by mass of glucose in spinal fluid would be 0.00375 grams of glucose divided by the 5 grams of spinal fluid, multiplied by 100% to put it in a percentage, and you get your answer 0.075%. And that's really all there is to it with these mass percent problems. Now let's look at a different example here. This problem states, concentrated hydrochloric acid is an aqueous solution of 37.2% HCl that is commonly used as a laboratory reagent. The density of this solution is 1.19 grams per milliliter. What mass of HCl is contained in 0.500 liters of this solution? Okay, well, let's think about things a little bit. What are we being asked to solve for here? Well, we are being asked to solve for what mass of HCl is contained in. Okay, so we've got 0.500 liters, so that is our volume of the solution. So we've got the mass percent of the solution, we've got the density of the solution, and we've got the volume of the solution. So we've got these three pieces of information, and we need to put them together somehow. Now this mass percent here, this only tells us mass HCl with respect to mass solution, but we don't know the mass of the solution right now, so we need to figure out what the mass of the solution is. Well, how can we do that? Well, let's take a look at the other two pieces of information that we're given. We're given the volume, right, 0.500 liters, and we're given the density. So we can use the volume and the density, right? We've got the volume, we can multiply by the density to find the mass of the solution. Now, once we've got the mass of the solution, we can use that mass percent as a ratio to find the mass of HCl. So let's look at those steps. First thing I'm going to do is I'm going to put that volume in milliliters since the density is in milliliters. Now I'm going to take my volume, 500 milliliters, and I'm going to multiply by the density. So 500 milliliters times 1.19 grams solution for every 1 milliliter solution. This tells me that I have 595 grams of solution. Final step is I'm going to use that mass percent as essentially as a ratio or as a conversion factor, right? Because 37.2% HCl, really all that means is that for every 37.2 grams of HCl, I've got 100 grams of solution. So I can use that as a conversion factor where I've got 595 grams of solution, and I'm going to multiply by 37.2 grams HCl divided by 100 grams of solution. So gram solution cancels. So I do 595 times 37.2 divided by 100, and this gives me my final answer, 221 grams HCl. So make sure you understand the logic behind this problem and how to do it if you are asked to do a problem like this. Okay, so knowledge check question. What volume of concentrated HCl solution, 37.2% by mass, contains 125 grams of HCl, and the density is given. So here you're being asked to find the volume. Okay, The correct answer here is D, 282 milliliters. So let's think about this one. Here we're being asked to find volume, Now we are given grams HCl and we're given the percent by mass of the solution. So I would start by doing 125 grams HCl, and I'm going to use that mass percent as a conversion factor, 37.2 grams HCl for every 100 grams of solution. Once I get whatever that mass of solution is, I would use that mass plus the density to find volume, and you end up getting D. The correct answer here is D, 282 milliliters. All right, next let's talk about volume percentage. Volume percentage, it's the same idea. Instead of mass percentage, we can also use volume percentage. So to calculate volume percentage, it's just the volume of solute, or whatever component you're interested in, divided by the volume of solution times 100. That's really all there is to it here. So let's quickly look at an example. Rubbing alcohol is a 70% by volume aqueous solution. If the density of isopropyl alcohol is 0.785 grams per milliliter, how many grams of isopropyl alcohol are present in a 355 milliliter bottle? Again, let's back up and think about what we're given. We're given a volume percent, we're given a density, and we're given a volume, and we're being asked to find grams. So the first thing that I notice is that, okay, well, I've got the volume and I've got the volume percent, so I can use the volume and the volume percent to find the volume of isopropyl alcohol. Then, once I have the volume of isopropyl alcohol, I'm going to go ahead and use that density to find the mass. So I've got 355 milliliter solution, and I'm going to multiply that by that volume percent. So 70 milliliters of isopropyl alcohol divided by 100 milliliters solution. So this tells me that in that bottle, I have 248.5 milliliters of isopropyl alcohol. Now I'm going to use that volume and this density to find the mass in grams. So 248.5 milliliters times 0.785 grams over 1 milliliter gives me my final answer, 195 grams isopropyl alcohol. Okay, last thing I'm going to talk about is parts per million and parts per million. I decided not to talk about volume and mass percentage here. So parts per million and parts per billion, they are used for really small concentrations. You often see them done in like a lot of the work the EPA does or environmental studies. They're usually either in PPM or PPB. Now, how to calculate these? It's actually really easy. It's a lot easier than you think. So parts per million, it's just the mass of the solute divided by the mass of the solution times a million times 10 to the 6th. Parts per billion is mass of solute over mass solution times a billion, which is 10 to the 9th. So just like percent, right? Percent is 1 for every 100. Per million is 1 in a million, and per billion is 1 in a billion. So these are calculated in the exact same way that percentages are. Instead, you multiply by a million instead of multiplying by 100, or you multiply by a billion instead of multiplying by 100. Okay, let's look at an example. According to the EPA, when the concentration of lead in tap water reaches 15 parts per million, certain remedial actions must be taken. What is this concentration in parts per million? And at this concentration, what mass of lead in micrograms would be contained in a typical glass of water, which is 300 milliliters, and we're going to assume the density of water is 1 gram per milliliter. So first thing we are being asked to do is convert from parts per billion to parts per million. So 1 parts per million equals 1,000 parts per billion. So 15 parts per billion is 0.015 parts per million. So that's the first step to the problem here. Second, again, we're assuming the density of water is 1 gram per milliliter, so the mass of the solution is 300 grams. Now let's think about our problem here. Well, I'm being asked to find the mass of lead in micrograms. So I'm going to take that mass of water and I'm going to put it in micrograms using this conversion factor. So 300 grams times this conversion factor gives 3 times 10 to the 8th. So that glass of water has a mass of 3 times 10 to the 8th micrograms. Now let's think about our equation here. So parts per million equals mass solute, which essentially is mass lead, divided by mass solution, which is the mass of the glass of water, times 10 to the 6th. So we are trying to find mass solute. So I'm going to isolate that variable. So mass solute would be equal to parts per million times mass of solution divided by 10 to the 6th. Our parts per million was 0.015. Our mass of solution was 3 times 10 to the 8th micrograms, and that's divided by 10 to the 6th. And our final answer is 4.5 micrograms. So 4.5 micrograms of lead in a typical glass of water is actually high enough where remedial action needs to be taken to start removing lead from the source of that tap water. Okay, let's have you try a knowledge check question. A 50-gram sample of industrial wastewater was determined to contain 0.48 milligrams of mercury. What is the concentration in parts per million? Okay, the correct answer here is C, 9.6 parts per million. So to calculate this one, I would take that mass right there and I would convert it to grams so I've got the same units. So that would be 0.00048 grams divided by 50 grams times 10 to the 6th. And this should give an answer of 9.6 parts per million. Okay, here are 6 practice problems for you to try. So as I mentioned before, take a few minutes, pause the video, and give these practice problems a try and see if you understand the material in this section. Once you have given these an attempt, you can move on to the next slide where you will find the answers. Here are the answers to those 6 problems. So that concludes Chapter 6. I'll see you in the next videos when we start Chapter 7.